Okay. Hopefully you're finishing things up. If you are done, send that towards the middle. I'm going to come get it, and then we'll see if I can get the problems right myself. Ooh, this will be good. This will be good. Good. Okay, so did everyone get a little half sheet of paper? You got extra? Okay, just want to make sure you got extra. I'll come get it in a bit. Yeah, this is for later because I didn't want to make you suffer and have to write everything down. In fact, Friday, you're going to get a big sheet of paper because Brad wants to have lots of numbers, and it's going to have a huge sheet of paper with lots of numbers on it. So, yeah, bring it on. Okay, let's go ahead and see how we did with this quiz, or see how I did. Unfreeze this. Sorry, I just took a photo of the. Just looks kind of bad though. Okay, so I did this one in my head. A versus B is a tie because both of them have what, 15, or no, not 15. They both have the same number. Yeah, 15 to 15. And then A versus C, C wins. B versus C, B wins. So here's the vote counts, or the points. And B is the overall winner with 1.5 wins. Think of it as a sporting tournament of some sort. Then drawing these lines to the correct stuff. Monotonicity is if you have a change that benefits the winner of the election, she should still be the winner. Like if a bunch of people decide to vote for this particular person who didn't vote for her, then she should still be the winner. Irrelevant, or sorry, majority. Majority is, well, that's the easy one. It says majority, right? Irrelevant alternatives is if one of the losers is eliminated, the winner shouldn't change. Kind of makes sense. Head-to-head criteria is if a candidate beats everyone else, then she should still be the winner. Um, that's everyone in one-to-one matches. So that's that. Okay, so we're moving on to this thing here. Just wanted to remind you that that we had this sort of chart here, and the check mark means that the particular criteria is satisfied by those methods. Now, this isn't to say that the board account will never satisfy the Condorcet criterion. But what this says is that board account could violate it. There are situations, sometimes they're cooked up, kind of like the homework. They were, carefully chosen to violate these particular criteria, but that it could happen. So when there's a check mark here, it means that it's impossible for someone to have a majority and not be the winner in a plurality election. Kind of makes sense, doesn't it? That if you have a majority, you for sure are going to get a plurality. Same thing goes with like instant runoff. Instant runoff, that's the elimination method. If you've got a majority of the first place votes, it doesn't matter. You can eliminate people one at a time, whatever. You're still going to be the winner. Copeland's method. If you have a majority, Copeland is the head-to-head method. If you have a majority of first place votes, then everyone prefers you to everyone else. Not everyone, majority. So there's no way you could lose that way either. So anyway, that's what this chart represents. But you'll notice that there is no method, at least not in this list, that satisfies all of the criteria. Copeland's method, the head-to-head method, is the closest. It's the closest. It does the closest to winning, but it's satisfying everything, but it still doesn't satisfy all of them. So what I want to do is, and then arrow, there, just mention this, for 3 or more candidates, no voting method can ever satisfy all 4 fairness criteria. So this is Arrow's impossibility theorem, meaning there is no way to be completely fair. That doesn't mean we shouldn't give up. So just because it's impossible mathematically to be completely fair, we should still strive to be as fair as possible. So one might argue that if we want to be as fair as possible, why aren't we using the head-to-head method in our regular elections? Well, one reason is that the head-to-head method is kind of a pain, isn't it? You have to do over and over again, figure out who's going to be the winner. It's inefficient. It's difficult to do. So you have that, which makes it difficult. Runoff is a pretty good method, although it's only, it only satisfies the majority criteria. So there is a method that satisfies most of the criteria that is not Copeland's method. And not only that, but when it violates a particular criteria, it's really hard to see that it's violating it. And so I kind of like this method. It's not being used, at least not widely by anyone, but this is a method called approval voting. Approval voting is where each person can cast as many votes as they want. They just say, here's who I approve of. We've used this in faculty meetings before for certain situations where you just cast a vote for everyone you approve of, and then we'll just count up the number of approvals, and whoever has the most approvals wins. Usually this is used when you need to elect more than one person to an office. It kind of makes sense to do it this way, vote for more than one. This is the idea with approval voting, is you can vote for multiple people. So here's what we're going to see when we have approval voting, is each person is going to say how many people they approve, or who they approve of. So let's go back to our original question back in when we were, whoops, there it is. We're going to vote again. Go to back to our original question of pizza, chicken patty, stir fry. Do you remember this? You know that we should have elected chicken patty, but for whatever reason, I forget. I think pizza won. Just doesn't make any sense to me. So here's what I'd like to do is I'd like to do this using approval voting just to illustrate how this works. So here you can vote for as many candidates as you want. Basically, you just say, I approve of this food, or I approve of this candidate. So if we, so you just decide, who do you approve of? Do you approve of pizza? Do you approve of chicken patty? Do you approve of stir fry? One way to think of this is, would you be happy eating these foods? Or maybe it's not, you need to be joyful, don't you? So let's go ahead and do this again. But now remember, you can vote for more than one. You can vote for all three if you like. But do you approve of pizza? I'll be honest, even though I prefer the chicken patty, I approve of pizza. So let's see. Raise your hand. Be proud of your pizzaness. Wow. All of a sudden, everyone is a pizza lover? 1, 2, 3, 4, 5, 6, 7, 8, 9. Done with this side. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 people. 21 people approve of pizza. I still am holding out hope for the chicken patties. You know what? Just to make it a little more dramatic, let's go to stir fry next. Do you approve of stir fry? Sorry. You can see what stir fry does to me. So go ahead, raise your hand. Be proud of your stir fryness. Stir fry? Come on, be proud of it. Let's go over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 people approve of stir fry. Now, the dramatic reveal. How many people approve of chicken patty? Chicken patty. Come on. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 14. Okay. So you can think of it this way, that if we want to make the most people happy, the most people will be happy with the dinner choice that we make. We're going to do pizza. Now, each one of us had a different sort of a different set of preferences. For example, let me just show you what I had for my preferences. Pizza, chicken patty, stir fry. It doesn't matter what order they're in. But here's where I voted. I voted for both pizza and chicken patty, but I did not vote for stir fry. So, how many of you, this is the last time I'm going to ask you to raise your hands. How many of you were like me and voted for just pizza and chicken patty? So let's see, 1, 2, 3, 4, 5, 6, 7. Seven of us voted for both pizza and chicken patty, but not stir fry. I imagine that some of you are different than me, because we're all different, right? That's what makes us, life so wonderful, is that we have such a variety of people. For example, Lucas, you didn't vote for pizza and chicken patty, did you? Let me try again. I wasn't paying attention, apparently. Kind of like Brad. Brad, you didn't vote for just pizza and chicken patty, did you? What did you vote for? All three. Some of you chose to be like Brad and say, I don't care what you feed me. I'm just happy to have some food. So if you're like that, you don't have to raise your hand. I just wanted to say, a number of people voted that way. A number of people, did anyone vote for only one of the three? You're a picky eater? Jack, which one do you prefer? Nice. Awesome. No, I love that. I mean, I don't love it that you have dietary restrictions. Is it a gluten intolerance or gluten celiac? Unbelievable. But you can have gluten? That's good. My wife can't have gluten, so I feel like she's sad. Which makes me sad because I can't have gluten either. So, okay. No, it makes total sense. So Jack is in the stir fry only camp, and that's okay. We each, I'm sorry, Jack. Pizza apparently is what we're having. Okay. Yeah, I know. This is my wife. She'll go to some like it's always donuts. Always. She was a school teacher for a number of years. Donuts always. Always. Yeah, I know. You just go get the donuts, and then you neglect all the people who can't eat donuts. But anyway, she was always good about it. Happy. Um, so this is what the approval voting is going to look like. I'm not going to fill this out completely, but what you're going to see is you're going to see a chart like this. The check marks mean I approve of these two foods, and if there's no check mark, I don't approve. Actually, if I was being honest, I would approve of all three of them. I'd be like Brad, but I wanted to make it more interesting. So let's take a look at an example. You have the first example. I didn't want to make you copy too much down. I have it right here. So here is the approval voting. Boring, it just is candidate A, B, C, and D. But I want to know who the winner is. Is A the winner, B the winner, C, or D? So take a minute, see if you can work it out. And if you're not sure, it's okay because we're going to do this together. Whew. Where'd it go? All right, like I said, we're going to take our time doing this. I know you've already got the answer, don't you? Well, let's just take our time and ask the question, how many people approve of A? So we'll just start with that. How many people approve of A? So Lila, how many people do you have approving of A? Just 3? I know, math is hard. Did you say 36? How'd you get 36? It's all those check marks. So 19 plus 14 plus 3 is 36. Very nice. All right, who's next on the volunteer list? Nick Klein, I know you want to tell me about B. How many people voted for B? Wow, 57. Now I'm guessing you did exactly what Lila did, but you just threw in the extra 21 because very nice. So very good. Let's get the last 2 vote counts and see who wins this thing. You aren't here to help me, but Dylan is. Dylan, what about C? How many people voted for C? Just 32? Man, C isn't very popular at all. And then finally, Ethan McNaughton. What about D? 64? Is that right? That was voter fraud? Yes. There was some voter fraud there. Let's double check. So Ethan, walk me through this calculation. What am I adding up? So, oh, you did it in your head?
Yeah.
So what are you doing in your head?
Well, I got 19, 14, and 11, but...
Okay, so you add those up.
14 and 11, I accidentally put 45 on my paper instead of 25. So then I did 45 plus 19, so 25 plus 19.
All right, and so it's actually 44. There's even more voter fraud. Okay, is it 44? Oh yeah, it is 44. If I could only add as good as you guys do, we're doing great. Very nice. Okay, this isn't too bad, is it? I mean, how difficult could this be? Okay, let's do another one of these, and then we'll talk about how this relates to the whole fairness criteria. So you've got the second one, it's already on your page there. I didn't want to make you have to copy all these X's down. So hopefully that will reduce the error.
Are the X's approval or disapproval?
Oh, approval. So the X's are approve. Apparently I was just too lazy to type the check mark from the whatever emoji. All right, let's see. Oh, I shut my phone down. Let's see. What is next? Ah, here we are. Tegan, we need the number of voters who vote for A or say they would approve of A. 24? Very nice. That's quite a few voters, so I think A is probably going to win, right? Well, let's find out. Jack. What about B? How many voters say B is approved? 20 how many? 22. Okay, so A is still in the lead. Onward. We're over to Abby C. Abby C. What about C? Just 18. People don't approve of C. All right, last one. Um, Sydney. Sydney, do you think you can do D for us? How many? Just 20? Oh, so I guess I was right. Uh, A does appear to be the winner, doesn't it? Or he or she? Very nice. Okay, so we need to deal with the mathematics involved. I know you feel like you've been doing math, but the real math, is when we ask these questions. Does approval voting satisfy the various voting criteria? And so we're just going to go through these one at a time, just to mention these. And then I want to just mention a couple things about approval voting that I think is somewhat compelling. But we'll start with approval voting ballots and Condorcet. Um, Maybe I'll save that one for last. Let's do monotonicity. Monotonicity is easy. So here, remember what monotonicity means. Monotonicity means if someone or some people change their ballot in a way that uh, improves the standing of a particular candidate, then that candidate should still win if the winner. So like the classic example is some voters change their ballots to say that they want the winner to be the winner, and suddenly the winner is the loser, which doesn't make any sense now that it's coming out of my mouth. But going back here, let's just take a look at this. This isn't really a proof. Mathematicians love to prove things, and what we do is we try to do them in general. That's why we love variables and letters, is because then we can say, if this works for all numbers, then it's going to work for your number, or your number, or your number. So let's just take a look at this. I know this is just an example, but I think we can get a feel for this. So the winner is A. So what would it mean for one or more candidate to change their ballot in a way that is advantageous to person A? There's only one way that they could do this. Well, actually, there's two things that they could do. They could either delete X's that are not A or add an X where there isn't an X for an A. So let's just imagine either one of those scenarios. First of all, let's just say these two people decide they like A after all. Is that going to, could you ever conceive of a situation where doing that would make A lose the election? Why not?
Because it just adds A's vote.
Yeah, okay, so A already has the most votes, and this is just adding to A even more votes. Okay, excellent. Look at this. Ethan is demonstrating what it means to be a mathematician. Okay, next, let's try the same thing, but let's do the opposite. Let's say that you pick some candidate, some one of these columns, and you decide to remove, because if you remove an X from someone else, that technically is helping A out. Is there any way that that could make A lose the election? No, same reason, right? A still has, you're just reducing the number for B in this case. So in this case, there is no way. So in this case, the approval voting and monotonicity is, there's a big yes. You satisfy monotonicity. If I was to make a chart like this with approval voting, approval, okay, that doesn't say approval. Okay, monotonicity, there you go. All right, let's do majority. Majority is an, sorry, majority is a hard one. Let's do the irrelevant alternatives. The irrelevant alternatives. Now, you'll notice that in every single case, irrelevant alternatives is not satisfied. In other words, I could come up with some crazy voting situation where a plurality winner changes because of someone dropping out of the race who is a loser. So anyway, and same thing with board account. This, by the way, is a major problem in elections these days, is irrelevant alternatives, because irrelevant alternatives is why it's so problematic for a third party to enter like a race like the national elections. They are essentially being taking the place of this irrelevant alternative. Like you have the Green Party candidate that may suck votes away from the Democrats, or the Libertarian candidate who might suck votes away from the Republican candidate and might change the election, even though they only affect a very small number of voters. So no matter what method you use, irrelevant alternatives is a problem. Well, check it out. Think about what we mean by irrelevant alternatives in terms of approval voting. Irrelevant alternatives says if one of the losers drops out, the winner shouldn't change. That's what the irrelevant alternatives means. So let's just imagine this. Take a loser, I don't care which one. Let's say D. Get rid of D. Is that going to change who the winner is? No, because we're just counting the number of approvals and it doesn't change any of the numbers. That seems like it's a pretty good thing to have happen with a voting method. For approval voting, you satisfy the irrelevant alternatives criterion. Now, as far as majority and Condorcet goes, these are much more difficult and more nuanced to deal with. So let's go to majority. Majority, yeah, we'll do majority first. You see, the problem with this is that I only have approval. I don't have a preference schedule. And approval voting, so majority criterion says if someone has a majority of first place votes, they should win. They should, win. My they has gotten separated. So that's what majority criterion says. And I can actually construct a situation. Let's see, got to remember how I do this. Okay, so here's first, second, third. So let's do this. Oh no, what just happened? Go back here. There. Okay, so we'll say three people would prefer A over B over C. And then one person would prefer B over C over A. And one person would prefer C over B over A. So let's say that we have this situation. There's just 5 people, all right? Only 5 people. But in this election, A clearly has the majority. Now, let me just present to you a plausible approval voting situation that is related to this. So let's just imagine those three people. So those three people, no, let's deal with this one person at the end here. So that one person, they may approve of both C and B, but they don't approve of A. Okay, I'm just spinning a tale here. This is what mathematicians do. We're looking for those edge cases. We want to know what could go wrong. We don't care so much about, well, we do care about what goes right, but we want to know, could anything go wrong? And this is something that could go wrong. Okay, so let's say that the one person there, this one person also approves of just B and C, or maybe no, let's say that that one person only approves of B and not C. This is a plausible situation. I mean, we could imagine this happening. Now, of those three people there, maybe they're divided into two camps, two and one. The two people, they're happy with either A or B, but they hate candidate C. Okay, once again, I'm just making this up. And then that one person is like, I am going A all the way, and I don't like either B or C. Now notice down here, using approval voting, A gets 3 votes, B gets 4 votes, and C gets 1 vote. So B is the winner, despite the fact that if you were to do the election this way, A would have a majority. Now, here's the thing, though, that I like about approval voting is when you do approval voting, you don't get to see this. And so no one knows that that would be the case. All we know is that more people approve of B than approve of A. And I like that. I like knowing that B is more generally liked. I'd rather have someone who is approved of more people, not the person who is the majority winner, even if there is a majority winner. So we don't see this, but suffice it to say that if we're being honest as mathematicians, and I've got to be honest as a mathematician here, approval voting does not satisfy the majority criterion. And for a similar reason, it does not satisfy the Condorcet criterion, which makes sense. We were told by Arrow's impossibility theorem, that no method can satisfy all 4 of these criteria. So anyway, we're stuck with this. However, I personally think approval voting would be a great way to hold elections, because that would allow people to vote their conscience, but also vote for someone who they think, like it would move us closer to the center. I'm a centrist, so I know that's maybe a bad word, like depending on how your family feels, like you might be all liberal and say, yo, centrists. Maybe it's the other way. But being centrist, if you have approval voting, it tends to pull people towards the middle, because they're like, I really like this super liberal person, but I could tolerate that person. Let's have the people that everyone could tolerate. What do you think, Ethan?
So isn't that kind of like trying to fit a square into a circle hole, though, to compare those voting methods?
It is to some degree, because we are doing, like, it's kind of like what I said back here is that you have, this is what would happen if we were to give people preferences, but we're not going to. So this is what we end up with. And so it does feel that way, but in order for me to evaluate whether or not approval voting satisfies the majority criteria, I have to figure out, does someone have a majority of first place votes, even though this doesn't have first place votes. So yeah, mathematicians do this all the time. We come up with some way of saying, well, this doesn't have first place votes in it, but we could imagine that that is consistent with this thing up here. And because they're consistent, this could technically violate the majority criteria, even though, yeah, it does feel like we're trying to shove a square peg into a round hole. But mathematicians are great with that. We have a subject called topology that allows us to change the shape of objects in order to shove that square peg into that round hole, as long as mathematically we're consistent about the edge. So anyway, that's my spiel, and I'll get off my soapbox now. Um, 10 minutes? 10 minutes. Yeah. Does anyone know how many electoral college votes Ohio gets? What? Sorry. Did someone say 40? No, it's more than one. Yeah, do you know how we figure out electoral college votes? Yeah, it's okay. So here's how you do it. Yeah, so this is how we elect a president. Elect a president by we each vote for each state votes for, and this is true for all but a couple of states. There are a couple of states that split their electoral college votes, but most of the states it's all or nothing. So Ohio, whatever candidate, like in the last election, I think we went for Trump. Okay, yeah, I love it. He sounds so disappointed about it too. But anyway, yeah, well, like I said, all of you liberals out there, you're like, not conservative. Anyway, I'm just centrist, all right? I want to bring us all together. But anyway, coming back to the situation at hand, Ohio, all 16 or so of our electoral college votes went for Trump, even though Trump only got maybe 52% of the vote in Ohio. This is the way most states are, but it's how we get the number of electoral college votes. Do you know where that comes from? It is related to population. It comes from the number of representatives we have in Congress plus the number of senators. So you take all of the representatives that we have plus our senators, and that's how many electoral college votes we have. So, for example, a place like Montana, Montana has one representative for the entire state of Montana. Who was saying that they didn't believe people lived in Montana? I think you're probably right. At least not very many people. Not very many people. Yeah. Yeah. So no, no, no. There's one representative. There are two senators. There are two senators. Every state has two senators. Montana has one representative. And so they have three electoral college votes. Now, backing up one more level, so anyway, so it's this convoluted way that we elect a president is with the electoral college. Number of votes comes from this weird calculation, 2 plus the number of representatives. Now we have to back up a little bit further and ask, how do we figure out how many representatives we have? So that's another question that we're going to have to deal with, and we're going to deal with that one on Friday. But I do want to mention that some of you might know when we started divvying up the House of Representatives. Does anyone know the history? You don't, but I was hoping that these two, even though I'm looking this way, when did the House of Representatives start, history people? Do you know when we ratified the Constitution of the United States? Okay, 1776 was Declaration of Independence. Constitution, Jack?
Well, I have the House of Representatives.
Oh, you know how many? Oh, there's 17 for Ohio?
No, I thought it was asking the year when the House started.
Yeah, the House started after the Constitution because it was a constitutional thing. When was it?
1789 is when it started.
1789 is Constitution.
Yeah.
First House of Representatives, 1792. So anyway, in 1792, we had to figure out how we divvy up. Anyway, I actually have Article 1, Section 2 of the U.S. Constitution that we're going to look at. It'll make at least the history people happy on Friday, and we're going to deal with that. So that's the next layer, is figuring out how we deal with that, because that's how we elect presidents here in this country. Okay, thanks for enduring. The homework should be easy. There's only two problems, and they're really simple.